Lesson 2, exact values theory. Now in part 1, we have a isosceles triangle here. Each side is 1, so these are 45 degrees. So we can see that the sine of 45 is equal to the opposite of the hypotenuse. Now the hypotenuse from Pythagoras is going to be the square root of 2. So it's 1 over the square root of 2. The cos of 45 is also 1 over root 2, 1 over root 2. And the tan of 45 degrees is equal to 1 over 1, which is 1. Alright, moving down. This time we take an equilateral triangle, each side of 2. So we drop a perpendicular down here. So this is 1. Being an equilateral, this has to be 60. And obviously this must be 30 degrees. So we can see that the sine of 60 degrees here. Now to get this one here, again from Pythagoras, that'll be 2 squared 4, 1 squared 1, which is 3. So this is root 3. So that'll be simply root 3 on 2. The cos of 60 is equal to simply 1 on 2. And the tan of 60, opposite over the adjacent, which is just root 3 on 1, or just root 3. And the other ones, the sine of 30 degrees is going to be equal to, looking this way, opposite over the hypotenuse, a half, which obviously is the complement of the cos, and the cos of 60. Here the cos of 30, beg your pardon. Cos of 30 degrees. You've probably got this now. Cos of 30 equals root 3 on 2, which is the complement of the sine of 60. And here we've got tan of 30 is equal to 1 on root 3. Now these are really important exact ratios to either derive like this or to memorize. Right, part 3. Now in this part we're going to find the exact values of sine 0, sine 90, cos 0, cos 90, tan 0, and tan 90, but tan 90 won't be an exact value. In fact, tan 90 goes towards infinity, as we'll find out. Okay, starting off with the sine. Let's time the sine. Okay, we're going to have sine of 0. That one first. Now, as theta goes towards 0, we can see that y will go towards 0. But the sine of theta is equal to y, or y on 1. Therefore, the sine of 0 is equal to 0 in the limit. Now, as theta goes towards 9 degrees, this time y will approach, as it gets bigger and bigger, 1. So the sine of 9 degrees is equal to 1 in the limit. Alright, so I'll just align those ones. So now we've got that one and that one. Okay, let's go look at the coses. The cos of 0. Now, as theta goes towards 0, x will go towards 1. Now, the cos of theta is equal to x on 1, or just x. So the cos of 0 is equal to 1, which is the complement of the sine. Now, as theta, rub this stuff out, sorry. As theta goes towards 9 degrees this time, we're going to see that x goes towards 0. So the cos of 9 degrees is equal to 0. Finally, the tan. Tan is 0. Now, as theta goes towards 0, y will go towards 0, and x will go towards 1. And the tan of theta equals y on x. So the tan of 0 will be equal to 0 on 1, which is just 0 in the limit. However, take the tan of 9 degrees. Now, in this case, as theta goes towards 9 degrees, we can see that y will go towards 1, but x will go towards 0. So here we'll have 1 on 0, and clearly 1 on 0 is not defined. Therefore, the tan of 90 degrees goes towards or approach infinity. Right, now, so we'll just underline that. Now what I've done underneath here is I've just drawn up a little table of exact values. And you can sort of memorize these if you like, but you'll see a certain pattern here. It's a summary of what we've been doing. So you can see it's starting to increase up to 1, and this one goes back the other way. So once you've got that line, you've automatically got this line. The tan is sine on cos, so 0 on 1 is 0. 1 on a half divided by root 3 on 2 becomes just 1 on root 3. The 2's cancel. This is 1 on 1. This is root 3 on 1 or root 3, because 1 on 0 approaches infinity. So that may be helpful rather than drawing up the triangles each time.